Hello. In this video, we will discuss the forward and backward chaining of artificial intelligence. As the name suggests, the forward chaining is the inferencing procedure starts from the variable leads to the goal. It is a variable-based inference procedure. Okay, the decision is based on the variable and that leads to goal state. The backward chaining is just the reverse. It starts from the goal state or the conclusive state and it inferences to the variable. It's a goal-based inference procedure, that is backward chaining. Now, starting with an example of forward chaining, starting the discussion with the very simple example of forward chaining, let's consider the knowledge base, a simple knowledge base that is indicated in the left side of the page. P implies Q, A intersection B implies L, A intersection P also implies L, L intersection B implies M, L intersection M implies P, and we have A and B two variables there as considered to be true. A and B two variables are there without any connective, which means A and B is pre-considered as to be true. Those are the true, the variables which are having the true values. So this is a small knowledge base that we have, which represented in a figure as shown here. The finally we have to arrive at the goal Q, we have to prove the validity of Q. We have to prove Q to be true. And that is the forward chaining. We start from A and B variables and we finally arrive at the decision that the Q is true. So that is a variable-based inferencing procedure leads to goal. Now here, as A and B two are true, let's start from the premise, the assumption that A is true. So what will happen? Previously, it is worth noting to say that these are the literals. Suppose the second premise of the knowledge, first premise of the knowledge base, P implies Q. There is only one literal, one variable in the left side, that is P. So we have marked as P as one. Here, we marked as one. That indicates there is a one literal in the left side. That is P itself. Now here, in the second premise of the knowledge base, A intersection B implies L. Here we have in the left hand side, there are two variables, A and B, two variables. So in the process of A intersection B or A and B, that implies L. So we have two literals A and B. That's why we have marked it as two. And we have marked the AND operators as the curve. This curve represents the AND operator, the AND connective. So this is basically an AND tree. This is basically an AND tree. Okay. So we have A and B connected with the AND operator, the AND connective, and leads to the L. So A intersection B or A and B implies L. There are two literals in the left side. That's why we have marked as two. Similarly, A intersection B implies L. So we have A intersection P. So A and P, we are connecting through the intersection logical connective. And since there are two literals in the left side, variables in the left side, so we have marked as two. That leads to L. And next we have L intersection B implies M. L intersection B implies M. We have two literals in the left side, L and B. So we have marked as two initially. And we have L intersection M implies P. L and M or L intersection M, the and or intersection represented by this curve. So it leads to P. It implies P. Since there are two literals in the left side, L and M, so that's why we have marked as 2 here. So this is the way we have represented at the initial stage. Now, as we have A and B as true, it starts from the presumption that A and B are true, which start from the assumption that A is true itself. Whenever A is true, so we left with only one variable to imply L. We know A implies B, A intersection B implies L, or A and B implies L. One of the variables in the AND operator becomes true means it left with only one variable that solely determines L, that solely implies L. A intersection B implies L. When A we know as true, so P solely implies L. So if B is true, L is true. If B is false, definitely That is the accordingly the thing will be done. So A is true, we know. So A intersection B is definitely is equal to B. So it is B implies L. It is B implies L. Okay. So if B is true, L is true. If B is false, L can be true. If B is true, L should be true. So this is the way we have. So B implies L solely says only one literal it reduced to, that is B itself. Similarly, we have P intersection A is implying L. We know A is true. So P will solely imply L. So P is the only literal in the left side now. So it's a 1. So it reduced to 1. So L is solely determined by B. Now, secondly, we know that B itself is true. Whenever we know B itself is true, there is no literal in the left side. So both true, true implies A intersection B, A and B both are true. So definitely L leads to be true. If A and B both are true, A intersection B leads to be true. A intersection B has to be true. A true always imply a true. So L is true. So we have zero literal in the left side. Similarly, as A we know as true and B we have already known as true. So there is only one literal. So far it was to imply M, that is L. L was unknown, but now L is known. So L is known to be true and B is also known to be true before. So we have zero literal to imply M, and M is liable to be true because L and B both are true. That's why L and B is true. True always imply a true. So M becomes true. So there is zero literal in the left side. Similarly, we have as M is true now and we have L already true. So there is L intersection M is always true and true implies a true. So that will lead to the P is true. And in the left side, there is zero literal. As we know the P is true, already we know P is true. And true always imply a true. So Q is also true. There is zero literal in the left side of P implies Q. And since P is Q, true, and A is also true, L again is proved to be true. Again. So we have this L. So these are forward chaining. Simple example in a diagrammatic way by which the forward chaining works, by which we can explain how the forward chaining actually works with the entry. Now the backward chaining. In backward chaining that starts with the goal state, that is Q. Q the goal state. If we have the P implies Q, this premise, if we have the premise that P implies Q, like in the previous way, the P implies Q, we have this particular assumption as true. We consider to be as true. This is the goal state. P implies Q. Q is the goal state. So we consider Q to be true. We starting from that assumption, we are proving the truth values of A and B. We will prove A and B will are true. We are starting from the assumption Q is true, that is goal is true. We are proving the variables. So it's a goal-based inference procedure. Starting from the goal, Q true, we are as assuming at the initial stage Q is true, and gradually we are proving A and B two variables are true. So how it comes? See here, it's starting from Q. It's starting from Q. As Q is true, then P must be true because P implies Q. P implies Q. For Q to be true, P has to be true. And for P has to be true, L and M both has to be true because L intersection M implies Q. L intersection M implies Q. So P to be true, these left-hand literals has to be true. The left-hand literal has to be true for the P to be true. The left-hand literal is to be true for the P to be true. So P is true. So we have L and M is true. So we have L and M is true. As we have L and M is true. So whenever we have this L and M true, then as we have L and M is true, so we can conclude L and M is true. So we can definitely conclude P is true already we have, L is true already we have, and P and A will imply L. P and L. So one of the left side is true, L is true, the other one that is A has to be true. Because P intersection A implies L. A is true, B is true. So A has to be true. Otherwise, it cannot happen. So A has to be true. So we know that A is true and L is true. So the other literal in the left side, B has to be true. So in this way, we prove B is true. This is the way. Now, we have proved A and B as true. Since A and B is true now, again we can check it. Again, check back. A and B true, that leads to L is true because A intersection B implies L. As L and B both are true, L and B we know as both are true. L intersection B implies M, which is true, which has to be true. As we know, M and L is true. M intersection L implies E. That has to be true. And we know P is true. Q has to be true. So this is the way we are actually proving the way of, we are showing the way of backward chaining as a reverse procedure of forward chaining with the help of entry and with the help of knowledge base. Now, the forward chaining actually, what is forward chaining itself? I'm starting the elaborating the concept of forward chaining as well as backward chaining. The forward chaining in propositional logic extends to first order logic. A similar restriction applies to the knowledge base, the implications, atomic sentences. The atomic sentences are leading to the goal state with the help of implications. The knowledge base can contain quantifiers. Okay, that is a existential quantifier or the universal quantifier. Those can be there. Okay, there are some examples of knowledge base. We are working with a knowledge base now, a bigger knowledge base, and we will show the process of forward training. Now, this is a knowledge base. Example knowledge base we have. Suppose the knowledge base is very common. It is found in almost all resources in the forward and backward chaining. Now, the knowledge base is, it is a crime for an American to sell weapons to hostile nations. So, when an American person sells weapons to hostile nations, it is considered to be a crime. It is considered to be a crime. So, how it is converted to FOL, first order logic? X is a variable. X is a variable that leads to a person. American is a function. X is an American. Intersection or and. Y is an instance of weapon. Y is a weapon. Intersection or and sells X, Y, Z. This means X sells Y to Z. X, which is an American, sells Y, which is a weapon, to Z. Z is something where X sells Y. Now, what is Z? Z is a hostile nation. Z is a hostile nation. Z is an example of instance of hostile nation. So hostile Z, it is written in this way. In intersection hostile Z. So that will imply X is a criminal. How? X is an American, Y is a weapon, and X sells Y to Z, and Z is known as the hostile nation. So definitely, according to this particular premise or assumption, X has to be criminal. X is a criminal. Now, no is a country. In our example, some missiles. We know it is having some missiles. That is a fact. That is a fact that we have. For at least one X, for at least one X, Nono owns X. Okay. Nono owns at least one X. Intersection or and X is a missile. Some missiles. We know what is the quantification of some. It may be one, it may be two, it may be three, it may be four. Okay. But not all missiles. Nono have some missiles. Nono is a country, has some missiles. Maybe one, maybe two, maybe three. So this quantifier is called a existential quantifier for at least one X. X is an instance of missile. X is a missile. X is an instance of missile. For at least one X, Nono owns X. It's a owns function of Nono and X means Nono owns X. Nono owns X means Nono owns at least one X, which is a missile. So X is an example of missile, instance of missile. So we have at least one X, Nono owns X, and X is a missile. Now owns function we have Nono M1 and missile M1. So this means Nono owns M1. M1 is a missile. Nono owns M1 and M1 is a missile. All of its missiles were sold to by Colonel West. Colonel West is a person that sells all the missiles. Okay, that sells all the missiles. All of the missiles were sold to Nono by Colonel West. So missile X, intersection owns Nono X, Nono owns X. Intersection X is a missile. This means X is a missile and Nono owns some X, Nono owns X. That implies the West sells X to Nono. West is a person, Colonel West is a person. So West sells X. We know X is a missile and Nono owns X, which means from where Nono got this X? He got this X from West. So West sells X to Nono. That implies X is a missile and Nono owns X. Implies if X is a missile and Nono owns X, then it is concluded that West has sold X to Nono. Missiles are weapons. So X is a missile implies X is a weapon. Okay, because missiles are weapon. So those are the assumptions that are converted to the FOL. These black marked sentences are the assumptions or premises. And these violet marked lines, those are the converted first order logic, FOL. Results. An enemy of America count as hostile. Whichever is the enemy of America is counted as hostile by America. So enemy function X America. So X is an enemy of America implies X is tagged as hostile. Hostile X. X is a enemy of America that implies X is tagged as hostile. West, who is an American? West is an American. So West is an example of American. West is a instance of American. And the country Nono, an enemy of America. So enemy example, Nono and America means Nono is an enemy of America. So these are the FOL conversion of all the assumptions of the knowledge base. This entire knowledge base is consisting of 1, 2, 3, 4, 5, 6, 7 assumptions, and those are the converted first order logic implications. Now, how to represent in first order logic? First of all, what we have? We have to start from the variable side. Then we have to go in the goal state. So what is the variable side? The variable side, left hand side typically is the variable. Left hand side is typically the, the reason and right hand side the result. So left hand side is the presumptions, right hand side is the conclusion. So we are starting from the left hand side. So what are the key variables we have? American X, and we have the other implications like enemy is an implication, American is an implication, and there are missile is an implication. Okay, American X, weapon Y, sales, hostile. So those are the left hand side we have. American, weapon, sales, hostile. So those are the things we have in the left. And here we have in the left missile and owns. So owns we have in both the cases. So now missile is our left hand side. We have missile. We have enemy in the left hand side in this particular FOL. Now we have marked, it starts with American missile owns enemy. American missile owns enemy. We are starting with these four variables, basic variables. West is an American. M1 is a missile. Nono owns M1 and Nono is an enemy of America. These four presumptions we are starting with. We are starting with these four basic variables, basic facts. Here are the basic facts. We have West is an American that comes from here. X is an American. Okay. X is an American. And we have Nono is an enemy of America. And we have West is an American. We have the West is an American. So in X is an American and West is an American. This first FOL and the last but previous FOL, we combine the first, the variable of the FOL, the first premise of the FOL and the last but previous FOL. If I combine, then West is an American. X is an American and West is an American. So we combine, we have West is an American. Next, we have missile M1. M1 is a missile. So we have here, we have missile X owns Nono X. And we have also missile X is a weapon X. Missile X means weapon X, means X is a missile, that implies X is a weapon. So missile X, we are having the missile X. X is a missile. X is a missile, that is another basic variable, basic fact that we are mapping. X is a missile or M1 is a missile because we have already defined as M1 because Nono owns M1 missile and M1 is a missile. This is a fact. So if I impose this fact, if I just apply this fact here, missile X in place of X, M1 will come. So definitely M1 will come because we are already declaring that M1 is a missile. If X is a missile, then X is a weapon. If M1 is a missile, then M1 is a weapon. That is true. So we are in the raw fact that we have raw data. We have M1 is a missile. And we have Nono owns M1. Here you can see the owns. Nono owns M1. That is a fact that we have. Nono has some missile. That is for at least one X. Nono owns X. Intersection X is a missile. So X is a missile. If I have an instance M1, M1 in place of X, then Nono ends M1 and M1 is a missile. That conclusion we can arrive to. Okay. For at least one X is M1. M1 means for at least one X. There can be M2, there can be M3, there can be M4, but M1 is an example of at least one X. We assume that M1 is a X. M1 is an example of X. So Nono owns M1. That is also true. Nono owns M1. An enemy. Nono is an enemy of America. So we have enemy function. Nono is an enemy of America. That is also the known fact. So these four known facts you are starting with. Basic known facts. Basic data. Okay. West is an American. M1 is a missile. Nono owns M1. And Nono is an enemy of America. We are starting with. Next step. What we have. If I combine these two, missile M1 and owns Nono M1. Missile M1 is a missile and Nono owns M1. So if I combine these two by the AND connective, this is the AND connective, that curve represents the AND connective. So if I combine these two, what it leads to? M1 is a missile and Nono owns M1. Okay. So what will be there? Just see. So what will be there? West sells M1 to Nono because it is already been declared that whatever whatever missiles are sold, that is being purchased from West. The West sold all the missiles. Okay. All its missiles were sold to it by Colonel West. Missile X intersection owns Nono X. This means X is a missile and Nono owns X. That implies from where it comes from West only. So this line is represented there. So intersection, missile X intersection, Nono owns X. So just see here, missile M1, Nono owns M1. Just in place of X, the M1 comes. So here we have cells West M1 Nono. Previously it was West X Nono. See here, it was West X Nono. West sells X to Nono. Nono is a country. West X is a weapon. West West is a person. West sells a weapon X to the country known. Now the thing changed because the value of X has become M1. So West is a person that sells M1 to Nono. That is a implication. Because from where Nono got M1, it can solely can get from West. So these two premises are ended to form this conclusion. And we have missile M1 is a weapon. M1 is a missile, that implies M1 is a weapon. So in the second step, we have this. And enemy, Nono is an enemy of America, that implies Nono is tagged as hostile. So these are the three premises we get in the second step. Now in the next step, what we have? The next step, this weapon M1 and American West. West is an American and M1 is a weapon. Okay. And also West sells M1 to Nono and Nono is tagged as hostile. So what does it mean? West is an American, M1 is a weapon, M1 is a weapon, and M1 is a weapon, and West is an American. West sells the weapon to Nono, and Nono is a hostile country. So all four ended together gives a conclusion: criminal. West is a criminal. That comes from this first one. If X is an American and Y is a weapon and X sells Y to Z and Z is hostile, that implies X is criminal. Exactly the same thing happens here. West is an American. Here X is replaced by the name West and X is replaced by M1. M1 is a weapon. And if West sells M1 to Nono, which is a country, that is Z, Z replaced by Nono, and Nono is tagged as hostile, all four implies West is a criminal. Just is a representation of the first part, the first FOL of this knowledge base. The first FOL, as you can see, is representing the last step, as you can see. So it reaches to the conclusion, the goal. The West is a criminal. So we are starting from the basic data, these four basic data, and we arrive at the conclusion at the end. So this is the thing. This is the FOL of the knowledge base from where the conclusion is finally being drawn. This is forward chaining example. Now we have the backward chaining, just the opposite, the backward chaining. It starts from the goal state, that assumption that the West is a criminal. And when we have the West is a criminal, then definitely X is an American, Y is a weapon, X sells Y to a Z, and Z is a hostile. These four assumptions that always follow from this: West is a criminal. And that is, we have this weapon X. Weapon X is implied that the Y is a missile. Weapon Y, that is implied by missile Y. Just the reverse process that it comes through. Okay. So we have previously what we have X West. Okay. X means is an American X. X West. West is X. West is an American. We have got this. Second step, weapon Y. So we have weapon Y implies missile Y because missile Y implies weapon Y. So from weapon Y, we are backward tracking to missile Y. Y is a missile. Next, M1. M1 is replaced by Y here. Okay. So Y is a missile. M1 is a missile. We have this. Then West sells M1 to Z. West sells M1 to Z. So why we have here M1 to Z. Z means no, no. Z means no, no. Okay. Z means no, no. We have Z is nothing but Z should be replaced by no, no. Okay. Now M1 is a missile and no, no owns M1. M1 is a missile. These two ands are true. These two operators on the left hand side should be true. Otherwise, this cannot be true. West sells M1 to Z. It is true when these two sub parts in the left side, literals, two literals, M1 is a missile and Nono owns M1. Okay. Because we know all the missiles are sold by West to Z and Z is Nono. So we have Z is Nono, Z slash Nono. So we have these two sub assumptions has to be true. As this sub assumption and this hostile Nono means hostile, who is tagged as hostile, which is a whichever is enemy of America. So hostile is true, that reversely imply that Nono is a enemy of America. Okay, because Nono is tagged as hostile means it is backward tracking. It will prove that Nono is an enemy of America, because enemy, whoever the enemy is implying, that will be tagged as hostile. As hostile is true, by looking at the truth value, we can include, we can definitely conclude it is the enemy of America. So we have this conclusion. So we have these four variables that we found. Okay, by the backward tracking, the backward chaining, just the reverse process, except we are exploring all the necessary possibilities, but in backward tracking or backward chaining, we are only going through the necessary steps. Thank you so much for this. I hope you have understood the example of forward chaining and backward chaining, and you can understand their examples and how to implicate. Thank you.